You ever wonder how these giant AI services, the big ones, seem to know everything but can also talk to millions of us at the exact same time? Well, it's not magic. Turns out there are two secret weapons working together behind the scenes. So let's pull back that curtain and see what's really going on.
So yeah, that's the big question, right? How do they tackle two massive problems at the same time? I mean, how can they give you this super smart, tailored answer while also dealing with a crowd that's bigger than the Super Bowl? The answer comes down to two key ideas, one for the brains of the operation and one for the brawn.
Okay, so picture this. You've just brought on this genius AI for your company. I mean, this thing has read the entire internet. It's brilliant. But on day one, you hit a snag. It knows all about the world, sure, but it knows absolutely nothing about your world. And that right there is our first major hurdle, what we're calling the brain problem. The AI's answers, they're just way too generic. It has no clue about your company's unique lingo, your specific tone of voice, or, the details of what you actually sell. It's a genius for sure, but it's not your genius. At least, not yet.
So what's the move? You gotta send it back to school. We need to give this generalist genius some specialized training, turn it into a real expert that gets your business inside and out. And this special training, it has a name, fine-tuning. The whole idea is pretty simple, actually. You take an AI that's already been trained on tons of data, a pre-trained model, and then you re-educate it using your specific stuff. So you're not building it from the ground up. You're just adding that crucial final layer of expertise. Here's a great way to think about it. Imagine a doctor who's just finished medical school. They have all that general knowledge, right? Well, fine-tuning is like sending that doctor to a specialized program to become a dermatologist, a skin specialist. The solid foundation is already there. We're just layering that focused expertise right on top. And get this, you don't always have to retrain the entire AI model. That would be crazy expensive. There are way smarter, more efficient ways to do it. For instance, there's this really popular technique called LoRa, which cleverly updates only about 1% of the model. It's cheap, it's fast, and it works incredibly well. And then there's another method, RLHF, which actually uses feedback from humans to teach the AI how to be more helpful and, safer. So, success. You did it. You fine-tuned your AI, and it's a huge hit. It's spitting out perfect answers, customers are thrilled. But wait, this massive success, it's just created a brand new, totally different kind of problem. All of a sudden, everyone wants to chat with your new expert AI. We're talking millions of requests flooding in all at once. And now we've hit the brawn problem. Your single genius AI, no matter how smart its brain is, just can't handle this enormous crowd. The whole system starts to slow down, it gets laggy, and poof, it crashes. Okay, to fix this, we have to stop focusing on the AI's brain and start thinking about its body. The actual computer system that it runs on. We need to give this thing some serious muscle, enough power to serve that massive crowd without even breaking a sweat. And the technique for that is called sharding. All sharding really is taking something gigantic, like a huge database, or even the AI model itself, and just chopping it up into smaller, much more manageable pieces. And we call those little pieces shards. Think about it like this. If one teacher had to grade 100 exams all by themselves, it would take forever. But what if you split that stack of 100 exams among 10 teachers? Now each one only has to grade 10. The whole job gets done way, way faster. That's sharding in a nutshell. You divide the work to conquer it. So there you have it, our two secret weapons. We've got the specialized brains, thanks to fine-tuning, and we've got the powerful brawn, thanks to sharding. And these aren't two separate things. They're partners. Every single major AI service out there relies on this partnership to be both incredibly smart and incredibly strong. Right, so the most important thing to remember is this. Fine-tuning is all about the AI's brain. It's what makes it smarter, more specialized. Sharding, on the other hand, that's all about the system's body. It gives it the raw power and capacity to handle a massive amount of work. Let's dig into this a little more, shall we? If you look at the main goal, fine-tuning is about improving the AI's knowledge and behavior. But for sharding, it's pure speed and capacity. That's it. Fine-tuning deals with the AI's internal code, its weights, while sharding manages the physical stuff, servers, data, GPUs. And here's the real kicker. Look at what happens when things go wrong. If fine-tuning fails, the AI gives you weird answers. If sharding fails, the whole service could just go dark. To boil it all down to one sentence, fine-tuning makes the AI an expert. Sharding lets the whole world talk to that expert at the same time. You just can't have one without the other. You absolutely need both.
And you can see this exact dream team at work in tools we use every single day, like GPT-4. The brain part, it was heavily fine-tuned using tons of human feedback, that's the RLHF we talked about, to make it helpful and safe. And the brawn, that massive model is sharded, split across literally thousands of servers. That's how it can handle millions of us asking it questions without even blinking.
Okay, so when we talk about making an AI smarter, fine-tuning isn't the only game in town. Developers actually have a pretty big strategic choice to make. It's kind of like deciding between teaching someone a new skill from scratch or just handing them a reference book to look things up in. And that leads us to a really important question. When does it make sense to use fine-tuning versus this other super popular technique called RAG? RAG stands for Retrieval Augmented Generation, and figuring out which one to use is a huge deal when you're building any kind of modern AI service.
You know, the choice gets a lot clearer when you just ask, what's my goal? You should go with fine-tuning if you want to change how the AI speaks, its style, its personality, its tone. You're basically teaching it a new behavior. But you should choose RAG if you need to change what the AI knows. You're giving it access to fresh information like today's news or updated company docs. And if you're worried about the AI just making things up, what they call hallucination, RAG is often a safer bet because it can point you to exactly where it got its information.
So, when it comes to fine-tuning, this is really the main thing to remember. It's not just about cramming more facts into its head. The real purpose is to fundamentally change the model's behavior, its personality, and how it actually interacts with you.
So what's next? Well, the cool thing is that both of these technologies are getting way, way easier to use. Today, using something like LoRa for efficient fine-tuning is pretty standard. But pretty soon, we'll see AutoML systems that just pick the best tuning strategy for you. And in just a few more years, sharding is probably going to become totally invisible, something that's just handled automatically by serverless platforms. You won't even have to think about it.
So, think about that. As the tools for building smarter brains and stronger bodies for our AI become practically automatic, it frees us up to think so much bigger. When the how is basically taken care of, the only question left for us is, what incredible new problems are we going to solve next?